For those of you watching or tuning in at home, I'm going to go ahead and pause the stream for just a second while I make some minor corrections. Actually, I'm going to go ahead and say that the stream is healthy again. Hold on. Okay. Recommended bitrate, use a stream bitrate of 9500K. Yeah, that's not going to be enough. So I'm currently debugging the stream quality, so stand by for just a second while I get that figured out for you. So for those of you tuning in at home, I'm going to go ahead and drop off just for a second here while I make some minor corrections to the streaming settings to see if I can get the quality up a little bit. The video output quality is a little bit low according to YouTube. So let me see what I can do here. Little technical glitches. Okay, so settings. To anybody who's just joining now, we'll be starting the stream shortly. If any of you viewing currently, prior to stream start, have any feelings or thoughts on the video quality and you want to type them in the live chat, that would actually be super useful right now. I just adjusted the stream settings because I was getting some error warnings from YouTube, so I'd like to try to get that stuff fixed if I can. Mark WHI1 in chat asks, may I sit by? And he absolutely may stand by. Thanks, Mark. Nick in chat says that the 1080p stream looks fine to him. Thanks for that, Nick. I appreciate it. I am encoding everything at 4K, so we'll see how that comes out for people. It's gonna be, I think it's gonna be a little dicey at the bit rate that I have, but hopefully that's gonna be a solved issue in the next couple streams. We'll see how we do. So hey, Kyle. Kyle has hopped into the stream to say hi. Well, I'm sorry you have to run off, but nice to have you in for just a second even. Okay. Yeah, Nick, I was expecting 2160p, but I actually think my theory here is that YouTube doesn't do so well with 4K when you're live streaming. So I'm trying to figure that out, whether the problem's with me or with them. According to my router, I'm not having trouble with that, with the bandwidth on my side, so it might be them. It's really hard to tell. Okay. Do a quick sound check here. Check, check. Okay. Cool. Does the audio sound okay to people listening in prior to stream start? Low, high, glitchy, anything like that? Whoa. All right, thanks again, Mark. Pretty much my hero today. All right, so we're now running a little bit late, so it's I believe it's time to get started. Let's double check that. Yeah. All right, excellent. So now that we have all of this up and running, let's get moving. All right, so welcome to my second live stream. I'm happy to have everybody here today, and thank you for those of you that tuned in on such short notice. I'm going to try to stream these or schedule them a little bit more in advance, but it's it's one of those things where I'm trying to still figure out my time and like how much prep it takes to actually get these things started and all of that sort of stuff. So kind of in the process of that now, but I wanted to do a quick live stream today, something like roughly 30 minutes, I'm hoping, and I'm going to tell you a few things. I'm going to give you a quick update on the studio, which, as you saw from the overview camera, is coming along relatively well. And I'm also going to do a quick teardown of a new Microscope camera that I bought that's going along with my new Microscope, which should arrive on Thursday. And then finally, I'm going to go ahead and do talk for just a quarter of a second about a new project that I'm working on. That's going to be a combination of live streamed and also created into or broken down into video segments for everybody's consumption. It's kind of fun. So thanks for tuning in, and yeah, let's get to the studio update. So kind of as you can see, I'm going to switch over to the overview here. Ignoring that stream start message, let's get rid of that just for now so people don't get confused. Whoa, having a little bit of difficulty there. This is going to be laden with technical difficulty. I'm looking forward to that. Okay, so taking a little overview real quick, you can kind of see what that the studio is starting to get fleshed out a little bit. I've got my desk set up here, which is great. I've got, you know, OBS and all that sort of stuff running on this machine, so I can do the broadcasting. I've got I've got my machine over here, the machine that I use for on-air stuff, as well as you know, everything that I, you know, ultimately my desktop work, and then I've got my notes. And then I've also started to get, you know, one of the things that you can't see is I've got a CNC mill from MakerBot. It's called a Carvey. And I've also got a Lulzbot TAS5 3D printer below that. There's everything from a drill press, like a small drill press, to kind of everything else. And I managed to fit this all in roughly 9 feet. Actually, it might be 8.5 feet by 7 feet. So this is the challenge of living in New York, right? Like when you live in New York, ultimately you have to deal with the challenges of living in such a small space. And so that's kind of what I'm doing now. So the next thing that I have kind of set up over here is I've got finally got a new workbench, and I've got, you know, my oscope and all of my basically my power supplies, voltmeter, that sort of stuff set up. And then I've got you know, my old microscope currently set up on the workbench, and smoke hood, all that sort of stuff. So, or not smoke hood, but fume absorber, all that sort of stuff. And then I have this delightful camera on this arm here, which is going to be used for over-the-shoulder shots, and it's kind of fun. It's on this nice articulated arm, so I can kind of swing it around and move it into shots, you know, to get shots when I need it. And that goes straight to that OBS machine. So, you know, as you can kind of see, everything's sounds like a little bit of audio clipping, so it sounds like I'll need to bring those levels down just a sec. I'm going to continue to read the stream as we go along, because that's the nature of the live stream. It feels like cheating if I don't do that. So yeah, so ultimately, you know, basically the plan here is to try to create a channel that's focused around kind of following me through the process of building the things that I build outside of the normal work that I do. You know, outside of my normal work, I'm really interested in design, everything from interface to industrial design. And I really enjoy, you know, electrical engineering and software development. And so, you know, my plan is to basically use this channel as a place where I can create products kind of from end to end, or basically take ideas all the way from conception to completion, and, you know, bring people along with me and hopefully, you know, teach them something, learn something from them, all of that sort of stuff. So that's the major goal here. So yeah, actually, I'd love to get started with this quick teardown, and the setup's a little bit rough still because I don't have a monitor over at my workbench yet, but we're just going to go ahead and try to do that. I'm still getting some reports from the stream, from the viewers of mic popping against the collar, so I'm going to go ahead and fix that real quick. I'm going to get to see some live on-air magic. Yeah, this is good. I'm going to stick that on the outside of my collar rather than the inside, so hopefully that'll help. And I'll keep an eye on the stream just to see if we run into any problems there as we go along. So yeah, I think the next step is really to get over there and actually get this started. So as we do that, I'm going to just transition over here and get this camera set up real quick, and we should be able to get started. All right. Beautiful. It's all coming together today. Okay. So let's hop over to that view. Actually, before I take a look at this camera and before we actually get started on the teardown, I do want to kind of outline and talk about what I'm tearing apart really quickly. So the thing that I'm tearing apart is this basically this microscope camera. So I wanted to purchase a new microscope so that I'd be able to show people that were viewing the stream kind of a really nice detailed versions of what I was working on. And kind of some of the finer detail. I mean, there have been times that I've worked in wood, and there have been times that I've been soldering. There's been all kinds of crazy stuff that happens, and I think that ultimately it's really important to be able to show that kind of detail as part of the stream. And so what I ended up doing was I purchased a new Microscope microscope, one of the trinocular ones that's capable of doing the continual stereo and camera at the same time, because there's a limitation on some microscope models apparently with that. And I also wanted to get I also wanted to make sure that I got a decent camera that was going to put out, solid 1080p video to this channel while I do that. So I ended up I did a bunch of research on this, and completely ignored everything that I found and went for something that was a little bit new and interesting. It's from from a Chinese manufacturer called, the seller was called AI Home, and the camera was manufactured by a company called Haier, Hayyear. And the interesting thing about this is that it's a 1080p microscope camera. It has a nice sensor in it, a Sony IMX185, which is 1 1/8 type, color CMOS sensor with rolling shutter. So it's not global, which is not a huge drag, but still trying to figure that out. And then the nice thing about it actually is also that the microscope itself has what looks like a computer built in, and it looks to be running Linux. That's just my guess, and we'll probably find out a little bit about that today while we tear things down. And I think that the computer that's running in it actually gives you all these really nice, interface where you can kind of click around and you can do things like really precise measurements from what you're seeing in on the camera, which is actually nice, or at least reasonably precise measurements. So the idea is it knows the camera's kind of constraints, and it can actually derive real world measurements from that. So I'll give you guys actually, I'm not going to have it hooked up, but I am going to show you the video demo that Yearha has published. So without the audio, just because it's really cheesy music that I'm pretty sure infringes on copyright claims. So let's get switched over there real quick. And actually, I think what we're going to do now is we can go ahead and start to take a look at this stuff. So I'm going to set up for this teardown. I've got my little over-the-shoulder camera here, which is going to be providing a little bit of imagery, and then I've got a second camera that's going to give a little bit more detail. So that should be reasonable. Let's see what we can do. Make sure I'm set up, and I'm going to go ahead and switch over to that OTS view. Excellent. All right. So, very exciting, I know. Just got a mess of lighting over here and trying to get kind of everything set up. So give me just 1 second while I figure that out. Okay. Yeah, excellent. So, just for a little background, this camera was actually a little bit expensive, and this is the more expensive version of something else that they offer that you can just buy on eBay for about $160. So it's not throwaway cheap like, I've seen a couple of Microscope cameras that are around the $60 to $100 range. But it is reasonably cheap. It's an investment, and I wanted to make sure that I was going to get something that I was going to see a good frame rate and good video quality out of. And I did actually want the measurement functions. I know that's a weird thing because it's mostly used for inspection, that sort of stuff. But from a reverse engineering standpoint, it actually seems kind of cool. So let's get started. It basically comes in this very nondescript little box, and what you get is a disc. A mini CD that has clearly been burned in somebody's machine, on their home machine. It's got 225 megabytes of storage. I haven't seen one of these for a really long time, but it turns out that you really, really, really do not need this CD. And there are plenty of ways to get video and photos and that sort of stuff off the device, including RTMP. So it actually supports acting as a webcam, and you can stream its content straight out to to OBS or something like that. I'm probably going to use the 1080p HDMI output, but we'll see how that goes. So going a little bit further here, we've got this tiny little mouse, which seems to be of reasonable quality, and it does not come with a with any kind of battery, I don't think, but it looks reasonable. It's very slim. It's completely not worth talking about. It does appear to be, I can't really decide if it's Bluetooth or not. It's of course marked FCC compliant and CE and all that sort of stuff, and it says 2.4 gigahertz, but it really doesn't tell anything more than that. So unless there's a little mouse adapter in this box somewhere, I'm guessing that it's Bluetooth, but we'll find out. And then it comes with this little Kingston micro SD adapter. And so in this micro SD adapter, there's actually a micro SD card, a little 8 gigabyte, so Kingston adapter, SanDisk card. And it appears that I really don't know what that actually has on it. I'm hoping that it's for photo storage and not for the OS, and that I haven't just bought something terrifying. But I'm guessing that it's actually for photo storage. Which, if it is, that's actually not a bad thing to have. It's kind of a throwaway these days, but that's okay. We've got a little, wall wart that it comes with, which is 12 volts at 1 amp. I think Mika Scott, Scanlime on YouTube, likes to kind of understand the quality of these by their weight. And this one is actually not at all heavy. But you know what is heavy is this thing. This thing has to be milled out of a solid chunk of aluminum because it is insanely heavy. And there isn't really much going on here in terms of heat dissipation or anything like that. There's a little bit of, there's kind of these indentations on the side, but they're not significant enough to really be useful from the perspective of heat transfer. And so I can't really figure out why they would go to the trouble of making something like this out of a solid block of aluminum, which is clearly what they've done, because this thing is just brutally heavy. In fact, you know what? This is so heavy that it's worth measuring. So I'm going to grab my scale really quickly, and I'm going to tell you exactly what this weighs. There we go. Okay, so the thing that I really like about this design, as opposed to some of the other microscope cameras that I've seen, is that this design is actually really compact. So this is only, not actually that thick. And again, just because I'm a stickler for accuracy, I'm going to try to give you an accurate measurement as to how thick this thing is. But it is actually much thinner than the other cameras that I've seen. So some of the other cameras that I was seeing were like 3 or 4 inches tall, which actually, the height is actually kind of annoying because it means that you are constrained. If you have it under your desk or something like that, it's not gonna ultimately work out well for you. So as you can see, this is 28.13 millimeters, which is not super thick. It is massive. I mean, it's just very dense. It comes with this nice little metal, well, let's see if this is metal or plastic, but I'm guessing it's metal. This little metal lens cap here. Nope, it's plastic, definitely plastic. And you can kind of see the sensor here. So let's see if I can get some good light just for a second. There we go. Yeah, so that's the sensor right there. And that's a Sony IMX sensor, which is awesome. It's not global shutter, which is not as awesome, but rolling shutter is passable here for sure, and especially for this price point, I can understand that. So that's that is what it is. So let's get started tearing this thing down, and hopefully I haven't bitten off more than I can chew, because I didn't actually prep for this in any sense. So I kind of just decided that I was going to tear this down live, and I haven't investigated kind of what is involved with tearing it down. So we're going to kind of figure that out as we go. And I'm going to go ahead and guess that it starts with these 4 screws in these corners here. So, oh, forgot to go through the box. Nothing else exciting in here. It does come with a USB cable, and it does come with one of those super thin, unshielded HDMI cables. So not super enthused about that, to be totally honest with you. And since I just moved, still haven't taken the tape off of my toolkit here. Free advertising for iFixit. But they do make a great screwdriver set. Let's go ahead and see what these are. Let me go ahead and guess it's one of these. That feels about right. Oh wow, yeah, those just come right on out. As I mentioned before, I do apologize about the view. I'm still trying to figure out getting the monitor and everything wired up over here so I can see the live stream. And I kind of have to look over my shoulder to see it, so things sometimes will not be centered just for this stream. I promise that's something I'm going to be fixing soon. All right, so I've got a few screws here. Let's get that 4th one out. Screwdriver is only so slightly magnetic. All right, so all of those screws are out. Yeah. All right. Look at that. So let's take a look real quick at this. Excellent. Okay, so what is in here? There are a ton of passives, and I like this little camera board. I actually really dig this flex connector that they've got here. This is kind of a nice little arrangement. Let me see if this is a pop out or a pull, and I can never remember. I'm gonna go ahead and guess that that's a pop out, but we'll find out ever so shortly. When I rip the cable. Maybe it is a lift up. Oh, yeah, it's a lift. There we go. Okay, so managing to remove the flat flex that goes to the camera board here, which is separate. And one of the things that's interesting that I'm noticing right now is that this camera board has got this really big connector on it, which does not appear to be marked. It's just marked as OC92. Which is either Orange County 92 or means nothing. So I actually don't know what that is, but I'm guessing that that's for potentially for some sort of iris control or zoom. It's hard to tell what this little SMT part is that I'm looking at that this goes to. It's marked 3522 by my eyes. and those traces are relatively thick. So I'm kind of wondering if maybe that's a little, you know, some sort of little H-bridge on a chip or something like that, and maybe that's designed to handle zoom traditionally. It's really, really simple, although, you know, there are no, well, I guess there are a couple caps on that. So yeah, that could be something something of interest. I don't, you know, I haven't actually seen any other models that do offer anything that I can think of that would need to be on this board. The only other model is a step down from this. Well, there's a few other models that they offer, but the only other model that's in somewhat of this form factor is a step down from this, and it doesn't have anything like an internal zoom or an iris assembly or anything crazy like that. So I'm not entirely sure what that would be. But you know, just for fun, let's take a look real quick. There is a nice little silkscreen map of these of all these passives here. Basically all decoupling caps, I'm guessing, for the sensor. But we can just take a look real quick and find out what's going on there. Just want to take a look at the other side of that sensor board just for fun. For those of you in chat currently telling me that the stream is down or that, you know, my computer's on fire and I just can't see it, I'm sorry, I still don't have visibility on my machine just because I have to turn my head to do it. And of course, that's a little bit difficult just at this exact moment. Cool. Just trying to remember the orientation of this thing. Yeah, that's nice. Got this nice little window. It looks like it's kind of a foam backed situation. So these, you know, there's a little, there's basically a little piece of, a couple of pieces of foam that have been stacked on one another to give this a little bit of profile, and just the sensor with what looks like an IR window in front of it. So pretty simple setup. It is nice to know though that I'm not going to be hitting the sensor if I do, for some reason, decide to poke a paper clip in that hole. You know, IR glass is easy to come by, but sensors not so much. So that's actually relatively welcome. This doesn't really have any markings on it. I am seeing a 2015 07's manufacturing date on the board. At least that's what it seems to say. It might just be a revision date, but it's hard to tell. And then a couple of test points, and really it just says the model number on this is YW3609A, and below that it says IMX180, referring to the image sensor. It's a Sony IMX180. So yeah, that's pretty basic. And the IMX180 is actually a great sensor. I've seen it used in things before, and it's got I think it's a 2.4 megapixel resolution, which is nothing to write home at, but it's also nothing to sneeze at. And it does have a high frame rate output, which is good for our applications. So yeah, let's see if we can, well, first of all, let's see if we can remember which way this went in. I'm just going to put it here for now. Don't worry about that later. This will be fun for me in the future to try to reassemble. I'm going to remove that flat flex from the other side of the board here, making sure that I'm somewhat in view. And using my flat flex fingers, say that 3 times fast. All right, so now we've got what looks like the main board here. So here's another interesting connector on the side here that has kind of the same, it looks like another JST connector like that other one that I saw on the camera board, but it's marked P13. So I'm guessing it's not related, but it's a bit difficult to tell. It looks, just given the proximity to the power connector, I'm thinking that it has something to do with that. You know, but we'll kind of see how that we'll see how that goes. From there, I'm not seeing, you know, there's not too much on this side of the board. It looks like there's a silicon image chip on this side. And I'm not actually super familiar with silicon image, so if anybody has some thoughts on that, that's always welcome. And then there's another unpopulated connector here, and then mostly, well, actually another unpopulated connector, which is P11, and I'm entirely unsure of what that does. It doesn't look like it has a standard number of pins for a JTAG connector or anything like that, so it's a bit hard to tell. So let's take off. You know, we got like what looks like a little tricolor LED here. The network stuff, which it looks like is a mag jack that has its own internal magnetics. So yeah, it definitely has its own internal magnetics. They're not going to be on the other side. So yeah, let's try popping this out and just take a look. I'm kind of curious what the. I'm guessing they're using an SoC for this, and I'm kind of curious which one it is. So this looks like it's held in by just a couple screws here. Excellent. Yeah, it is in fact. Oh wow, this is. Yeah, see, this has got some real heft to it. It's just a thick piece of equipment, and you know, not poorly done, not poorly done at all. And it does look like it's not necessarily milled, but maybe yeah, maybe just a mold. But yeah, it's definitely not milled. Yeah, they've got the punch parts. So yeah, that's not anything exciting. But let's get this flipped over and take a quick little look. All right, so this is the exciting side of the board. So, wow, all right. So there's a little sticker on here that says, looks like it has a date code on this, which I'm gonna ignore, and I'm also gonna remove it just briefly so I can get at the SoC below it. Wow, all right, this is gonna be difficult. They've chosen to make this a challenge. Let's see what we can do about that. Fumbling around in my drawers here for X-Acto knives. Yeah, there we go. That'll do it. Never underestimate the value of a good X-Acto knife kit. There we go. All right. So, taking a look at this, it's actually kind of difficult. I don't recognize, and this just may be my naivete, but you know, I would have thought I had seen this before at least once. I don't actually recognize this manufacturer. It's HI is kind of the logo there. It's got this, for those of you that can see this, it's got, you know, a little HI in a circle, and the chip number is HI3516, I believe. Yeah, it's going to be HI3516. That is correct. Yeah, I'm not really entirely sure what that is, but I actually kind of want to look. So I'm going to grab my iPad. Well, actually, you know what? I'll do this live for you guys so you can see too, because I'm sure you're curious. Let's take a look. All right. And we'll pop back over to the All right, it sounds like you guys lost audio for a second. Thanks. I'm glad that I looked at chat because Scanlime and Microhex pointed it out. So basically, all I was saying is, there's nothing really to write home about this thing, but it looks like the SDK is based on Linux 2.6.35. So I'm sure there are all kinds of exciting security holes and that sort of stuff that I will want to be looking out for. I am just saying that without having referenced it, but it's probably fair to assume so. I shouldn't connect this to my network, I'm guessing. It's really just not that exciting. Here's a quick block diagram, though. A little bit of DDR2, DDR3 RAM here, 500 megahertz interface, SDMMC interface, GMAC-PHY, not too exciting. 2-port USB interface, the video subsystem, PCIe 1.1, that's nice. Yeah, so it's just really simple. And the one other thing that I mentioned while you guys were missing audio, or while you folks were missing audio, was that it does have this BT1120 VO interface for connecting to the external HDMI or SDI. And I really actually do wish that it had SDI, just because that's pretty much what I've standardized on in my shop. But I would love to know I'd kind of love to know how difficult it would be to get the SDI working on that. And I'm guessing that it's actually pretty challenging, just because SDI usually requires some sort of interface chip. It's not something that you can really, I'm guessing they're really going to stick on that chip. So yeah, let's pop back over there and continue this. Just a quick little review here. So going to do that. And I still have audio, so that's going to be good. All right. So yeah, the other stuff that's on here is not too exciting. We've got a little bit of Samsung DDR here, little SRAM, and then we've got, let's see, some really basic power handling stuff. Well, not basic, but not super interesting. And then we've got this MXIC. I'm not entirely sure exactly what that is either, but I should take a look at it. It doesn't look too exciting, though. I'm guessing that has something to do with the Ethernet, but it's a thick package, but it's a little bit difficult to tell. So yeah, I mean, you're not missing out on anything. This is not, like I said, nothing to write home about. It's nothing too complex, but it is I kind of do make it a habit to tear pretty much everything that I buy apart, just for the sake of taking a look at it and knowing what's in it, so that I can figure out how to fix it later, or kind of build that mental model that's necessary to to figure out where things might be failing. And in some cases, I'm not going to do that, but in other cases, if I'm, for example, had I plugged this into my trusted VLAN on my network, and I was suddenly seeing weird traffic across the network or something like that, it's probably pretty unlikely, but I might say to myself, oh, this little the little SoC that's running on this on my Microscope is running an outdated version of the Linux kernel, so maybe there's something going on there, right? So that's just useful information to have, kind of, period. And it doesn't really, it doesn't hurt to tear things apart. I think that's kind of like, that's the fun of that's half of the fun of buying something new for me, is to just tear it down and see how people did things. So as exciting as that was, I'm actually going to call that a day and kind of move on to the next part of this, which is actually talking through a project that I'm working on. So I'm going to switch back to the other desk now. And yeah, as Microhex mentions, 1080p is definitely going to be sufficient for streaming electronicsy type stuff. I do want to try to get more of this channel over to 4K. Oh wow, I've got a stuck camera. That's good. Here, I'm going to pop back over there while I unstick this. Although that is a great look for me. These are the kinds of things that you deal with in a live production environment. Here we go. All right, so now that we've got video back, even for just a second, perfect. Yeah, so Microhex also just commented, Blackmagic Studio Micro, 4K video on SDI for only $12.95. and that's $1,295 for you following along at home. And actually, I looked at those cameras and I really, really liked them. But what I ended up doing was going with kind of just this melange of like cameras that I could find, because not only did I not want to put $1,200 into each camera in the studio, I also just kind of wanted to be able to feel good about you know, recycling a little bit of electronics on the way to building this thing out. And so this camera that I'm using right now, actually, that you're looking at, is a Sony. It's a Sony a6000. So that's a great little camera. It outputs tremendously good video. It's an E-mount lens. You can do all kinds of really nice stuff with it. And I just kind of have it fixed. But I picked it up on eBay for $400. So it's kind of nice to just be able to reuse a little bit of the equipment that I have. And I think that over time, what I'm going to do is I'm going to start to move more of the studio over to these like 1080p cameras, and potentially over to 4K stuff. This guy behind me is a Sony a7R Mark II, and it can output 4K video. It just can't do it with the Blackmagic cards over a 30-foot cable, which if you can kind of, just to give you an idea of what's going on in the studio above, I'm going to just take this off real quick and I'll show you what the ceiling looks like, because you can see how I have things wired a little bit more, and that's just always fun. So let's see. Pull this guy out of here and just pop this really big stupid lens off of this thing here. So, all right, internal temp is high, allow it to cool, is what the camera just said to me. So that doesn't bode well, but hopefully we'll be able to get this thing talking to me again. It does overheat a little bit, which I'm not a huge fan of, as you can imagine. So let's pop back over here. Cool. Yeah, there we go. Okay, so switch to this OTS shot, which is going to let us see. There we go. So this is what the top of the studio looks like right now. I've got these compression poles in place that kind of allow me to avoid marring the wall in this little apartment that I have. And they basically, you just squeeze the ends of them and they compress against the walls and ceiling, and they extend up to something like 14 feet, which is phenomenal. And I have the cable cable running down and all the way over to this Manfrotto arm that I use for capturing this stuff. I have a hair light up there, all of my networking gear, a bunch of other random stuff. That was the house camera, that one up there that you're seeing, and then my 24-volt shop supply behind that. A temporary cable that's going to my my desk to power my desk lamp for now, because I just haven't wired in a 24-volt connection for the shop supply. And then the two machines that are ultimately, lots of camera gear, and then the two machines that are ultimately processing part of this. The one on the right, which is called Omega, is doing all the work necessary to process the video, and I've got my little Behringer audio interface there. So nothing too exciting, but you have to love these polls, because it just makes everything so unbelievably easy. Oh, and here's the star camera here that I'm using, that I was mentioning earlier, and this is a Sony a7R. It's an absolutely excellent little camera, and it gives you kind of this really nice, I mean, you're seeing my star shots, but like, it gives you nice, relatively smooth video out. It's got some nice features, and if you actually wanted to take it off the tripod ever, which I don't, because I have it wired in via a little battery connector, it basically just pulls the it outputs clean HDMI that's usable, and if you want, you could record to it, but I don't. So yeah, pretty simple little setup. And the other thing that I use that people might like is I use these little tiny articulated little articulating arms that tighten and untighten for just about everything. I've got hundreds of them, and they're used for kind of everything from like, connecting, like this is my little Viltrox SDI monitor, and I use it for that. And you can buy these little like C clamps for them that tighten up, and you can put them on anything that basically has a pull, which is like everything. So yeah, it makes things pretty easy. So I'm going to drop this back in, and now I'm going to tell you what I'm working on next, which I think is the more exciting part of this announcement today, or at least this little live stream. Let's drop that back, and it's, there we go. You can see the aftermath of my little teardown there. Okay, excellent. So switching back. Okay, so the third thing that I have on the list for everybody here today is I wanted to talk about, at the start of the stream, I talked a little bit about what I'm working on in the larger scope of things, and like what I was gonna talk to you about today. And one of the things that I'm gonna talk to you about today is I'm gonna actually announce one of the projects that I'm gonna be working on this channel, and hopefully with anybody that feels like collaborating in any way. And it's interesting. So basically, one of my personal passions is interface design. And the best interfaces are kind of those which leverage the independent strengths of both humans and machines, right? So you let the machines do the part that they're really good at, and you let the humans do what they're really good at, right? And there are a lot of companies that do this really successfully. Companies like Palantir, for example, if you've heard of them, they're a little bit on the evil side, but they also have, like, one of their biggest strengths is that they've just kind of isolated that ability to use humans for the part that humans are good at, and have an interface that does that allows them to basically capitalize on the fact that humans are good at spotting connections and humans are good at kind of drawing conclusions, whereas machines are currently terrible at that, despite what all of the Silicon Valley AI hype kind of says. And so, one of the really interesting areas of computing that's kind of not talked about right now is this area called affective computing. And that's affective, A-F-F-E-C-T-I-V-E. Affective computing is essentially the idea that you would like to be able to have computers understand emotions and be able to, react in some way that improves the interface, or that improves the experience, via just being able to sense your emotion. And so this has kind of been something that I've been really interested in for a long time, but there's not a lot of capability out there currently. There's a lot of like really basic approaches to it, right? You can build a classifier that's capable of looking at your facial expressions, and it might be able to, if you have really exaggerated facial expressions like heavy frowns, that sort of stuff, you might be able to pick up on it. And then there's more invasive processes like galvanic skin response and that sort of stuff. And you have to be very wired up to a computer in order to do that. And I don't really like that either. But one thing that I've been playing with recently is I've been kind of getting into VR a little bit. And I've got, I managed to get an HTC Vive, and I've kind of gotten that working. And one of the things that I realized is that this is kind of the perfect platform to work on affective computing problems, because what you can do is you have the physical interface that normally would actually affect emotion and would actually affect is basically too intrusive. You have that physical interface to the skin, to the face. And so my theory is that what you need to do is you need to be able to have a large number of sensors on this platform that are going to capture enough information about you and about your biometrics, your attentiveness, your movement of certain facial muscles, etc., that you're going to be able to reconstruct a user's emotional state, and also and basically reconstruct as much as possible about their mental state from the sensors on this, right? And so the thing that I'm going to be working on is I'm going to be re-engineering. I'm going to be designing a new face mask for this. So a new face mask portion that actually embeds all kinds of sensors into it to be able to pull that information together. So the goal is to have things, for example, like pupillometry and gaze direction, and biometrics such as heart rate, and EM, like electromyography, and basic like single channel EKG, that sort of stuff, so that you can start to pull that data out, pull it into algorithms that are capable of analyzing it, and then build interfaces for the virtual environment that change based on the user's emotional state. The other kind of area that I'm really interested in is building interfaces that allow people to work very quickly with high volumes of data, because humans are actually great processors when you get them into kind of a rhythm. So you can look at something and you say, oh, okay, I'm gonna show me make a yes no decision very, very quickly on these things that are kind of coming at you, or this information that's coming at you very quickly. And I want to be able to actually harness that and kind of leverage those capabilities inside the VR environment to allow me, for example, to process more information than I would normally be able to much more quickly. So that's ultimately the project that I'm going to be working on, I think, over the next month or so. And I'm going to be interspersing that with all the kind of other stuff that I want to do for the channel. So the goal is to do a few videos about sensor technology, which obviously is going to be involved in this project, as well as teardowns, and as well as just random engineering projects and tips and sort of stuff that I have lying around. But the goal is to get to a place where I can really take this project, come up with something, basically replace this face mask part, embed sensors, build the necessary computer vision tools and algorithms that are that are needed to actually process the information coming from the sensors, and then hopefully release it all on GitHub so that everybody can kind of create their own. So that's kind of the next big thing. So I'm hoping that people will be interested to follow along. And then, I think that the next little segment that I'm going to be working on is called the sensor segment, and it's going to be kind of a conversation about sensors, about different types of sensing technologies. And one of the things that I mentioned, I think, in a previous video that's really fun is that I have a fiber optic ring gyro, and I want to do a little comparison of that to normal gyroscopes and kind of see how drift changes, and talk about the different characteristics, and then tear it down, because it's not something that you get to see or would ever almost run into in the real world unless you're working on either not even self-driving cars. I'm trying to think of something that would have them. Mostly aerospace stuff, and it's a really cool thing to play with. So I'm hopefully going to show that off, and there's all kinds of stuff coming in future videos. So unless anybody has any incredible questions, I'm probably going to go ahead and wrap up the stream, but I did want to thank everybody for stopping by really quickly. And it's always good to have people in, and always good to have the feedback on the quality of the stream. And it's hopefully something I'm going to be iterating on over the next few months. So we'll see how that goes. Thank you so much for joining. I'm going to go ahead and wrap up. Also, hello to, just hanging out for chat for a second, but hello to Wild Mania and everybody else that joined. Thank you so much for joining. It's always great to have people in chat. So I'm going to read through this and kind of see what I missed over the while I was staring at my teardown over there. And thanks to Kyle, who says he only saw parts of it, but the stream went well. So thank you.